In this section, we will learn how to take the derivative of a function that multiplies and/or divides two functions. The product rule says if f of x is equal to u of x times v of x, where u and v are differentiable functions of x, then f prime of x is equal to u of x times v prime of x plus v of x times u prime of x. Let's go ahead and prove this, and let's start with the limit definition. The derivative of u of x times v of x is equal to this limit here. Now what we're going to do is we're going to introduce a term that's going to allow us to manipulate this algebraically. So that is equal to the limit as h approaches 0 of u of x plus h times v of x plus h minus u of x plus h times v of x plus u of x plus h times v of x minus u of x times v of x all over h. And notice that this here plus this here will cancel out and make 0. So we haven't really changed the value of the thing that we're taking the limit of. We've just kind of changed what it looks like, but it still holds the same value because the highlighted items, if we add them together, form 0. So now we're going to do some factoring. So I have the limit as h approaches 0. And I'm going to factor out u of x plus h, and then that leaves v of x plus h minus v of x over h. And then I can separate this using a limit property. And from these next two terms, I want to factor out a v of x. Over h. So now we have these two limits, and we want to simplify this. So I'm going to go ahead and separate these into separate limits. So this is the limit as h approaches 0 of u of x plus h times the limit as h approaches 0 of this thing Okay, so there's a slight thing we have to think about, and here u of x, or u is a differentiable function. So u is differentiable, and we learned in a previous section that if a function is differentiable, that implies that u is continuous. And why is that important? Because when a function's continuous, we can just plug in the limit value into and substitute it indirectly. So what this becomes then is this becomes just u of x, because basically we've substituted h with 0. Now this thing here, this is just the definition of v prime of x. So then we have times v prime of x plus, here we just have v of x, and it's not, there. Notice that there's no h, and so v of x is just a constant basically in terms of h. So we just get v of x, and then the last thing here, this is the definition of u prime of x. And so we get the result that we wanted, and that concludes our proof. Let's put the product rule into practice. Now, example 1 wants us to differentiate f of x equals x squared minus x times 3 plus 2x. And this function might seem familiar because we actually found the derivative of this function in a previous section. However, this time we can use the product rule and we don't have to multiply it out immediately. So we can do f prime of x is equal to the first function times the derivative of the second function, which is 2, plus the second function times the derivative of the first function, which is 2x minus 1. And normally you can leave it unsimplified, that's fine, but let's simplify this so that we can confirm that it matches what we got last time when we found the derivative. So we have f prime of x is equal to 2x squared minus 2x. I just distributed the 2 in. And then plus, we're going to have to do some foiling. So 3 times 2x is 6x, minus 3 plus 4x squared minus 2x. So that's going to give us 6x squared plus 2x minus 3. This does match what we got last time. The quotient rule says that if f of x is equal to u of x divided by v of x, where u and v are differentiable functions of x, and v of x is not equal to 0, then f prime of x is equal to v of x times u prime of x minus u of x times v prime of x all over v of x squared. If you'd like to see a proof of this, there is one available in the textbook. Example 2 says, differentiate f of x equals x cubed plus 2x squared all over x. So if we're using the quotient rule, that's going to tell us that we want the bottom function times the derivative of the top, which is 3x squared plus 4x minus the top times the derivative of the bottom, which is 1, all over the bottom squared. So let's go ahead and simplify that. So we have 3x cubed plus 4x squared minus, I'm going to go ahead and distribute that minus sign in. So we get minus x cubed minus 2x squared all over x squared. And that's going to give us 2x cubed plus 2x squared all over x squared. And then both the terms in the numerator have an x squared in them, so then that can change into 2x plus 2. Let's check if we did this correctly. And the way that we can do that is we could actually notice that both of these terms have an x in them, and so we can divide to begin with. So if we rewrite this from the beginning, x cubed plus 2x squared over x, I could factor out an x in the numerator. And so the numerator and the denominator, those will divide out there like that. So we have f of x is really equal to x squared plus 2x. And now I can use the power rules to take the derivative. So f prime of x will equal 2x plus 2. And look, that matches with that. So can put a check mark. We've confirmed that that is in fact the derivative.